Welcome to PSY 503, Internal Consistency of Test, Study Session 10. Introduction. In addition to the reliability methods discussed in Lecture 9, there are other advanced methods of establishing the reliability of psychological tests. The methods discussed include the coefficient alpha, Kudar-Richardson, average inter-item correlation, and average item total correlation. Objectives. This lecture will expose students to the following. 1. The meaning of internal consistency in establishing test reliability. 2. How to compute coefficient alpha. 3. How to apply the Kudar-Richardson formula 20. 4. How to compute inter-item correlation and its role in establishing test reliability. 5. How to compute item total correlation and its relevance in establishing test reliability. 6. Identification of the sources of error variance associated with each method of establishing reliability. Content. Internal consistency is commonly measured as Cronbach alpha based on inter-item correlations between 0 low and 1 high. The greater the number of similar items, the greater the internal consistency. That is why you sometimes get very long scales asking a question in a myriad of different ways. If you have more items, you get a higher Cronbach. Generally, alpha of 0.80 is considered as a reasonable benchmark. Internal consistency reliability refers to how well all the test items relate to each other. Imagine that we compute one split half reliability and then randomly divide the items into another set of split halves and recompute, and keep doing this until we have computed all possible split half estimates of reliability. Cronbach alpha is mathematically equivalent to the average of all possible split half estimates, although that's not how we compute it. Notice that when I say we compute all possible split half estimates, I don't mean that each time we go and measure a new sample. The figure below shows several of the split half estimates for a 6-item scale and lists them as SH with a subscript. Although Cronbach alpha is equivalent to the average of all possible split half correlations, we would never actually calculate it that way. Some clever mathematician, Cronbach, I presume, figured out a way to get the mathematical equivalent a lot more quickly. We can estimate the proportion of true score variance that is captured by the items by comparing the sum of item variances with the variance of the sum scale. The formula is given thus: R equals to N bracket SC2 minus ESI2, where N equals to number of test items, SC equals to the S.D of total scores on the test. SC square equals to square of ST square equals to square of ST, that is, variance of total scores on the test. SI square equals to the variance of all individual scores for each item. ESI square equals to the sum of the variance on all items in the scale. Note, the calculation of coefficient alpha is a must for any newly developed personality test. If all items are perfectly reliable and measure the same thing, true score, then coefficient alpha is equal to 1. If there are several subjects who respond to test items, then we can compute the variance for each item and the variance for the sum scale. The variance of the sum scale will be smaller than the sum of item variances if the items measure the same variability between subjects, that is, if they measure some true score. Technically, the variance of the sum of two items is equal to the sum of the two variances minus two items, the covariance, that is, the amount of true score variance common to the two items. 7. Average inter-item correlation. The average inter-item correlation uses all of the items on our instrument that are designed to measure the same construct. We first compute the correlation between each pair of items as illustrated in the figure. For example, if we have 6 items, we will have 15 different item pairings, that is, 15 correlations. The average inter-item correlation is simply the average or mean of all these correlations. In the example, we find an average inter-item correlation of 0.90 with the individual correlations ranging from 0.84 to 0.95. 8. Average item total correlation. This approach also uses the inter-item correlations. In addition, we compute a total score for the 6 items and use that as the 7th variable in the analysis. The figure shows the 6 items to total correlations at the bottom of the correlation matrix. They range from 0.82 to 0.88 in this sample analysis, with the average of these at 85. How reliable should tests be? Some reliability guidelines. High reliability is required when tests are used to make important decisions, and individuals are sorted into many different categories based upon relatively small individual differences, e.g., intelligence. Lower reliability is acceptable when tests are used for preliminary rather than final decisions, and tests are used to sort people into a small number of groups based on gross individual differences, e.g., height or sociability, extraversion. Reliability estimates of 0.80 or higher are typically regarded as moderate to high. Approximately 16% of the variability in test scores is attributable to error. Reliability estimates below 0.60 are usually regarded as unacceptably low. Levels of reliability typically reported for different types of tests and measurement devices are reported in Table 7 to 6. Murphy and David Schoffer, 2001, page 142. 0.90 equals to high reliability. 0.80 equals to moderate reliability. 70 equals to low reliability. Summary of reliability and sources of error variance. Any reliability coefficient may be interpreted in terms of the percentage of score variance attributable to true or error variance. A reliability coefficient of 0.85 signifies that 85% of the variance in the test scores depends on true variance in the trait measured, and 50% depends on error variance. End of study session 10. Thanks for listening.